Hello everyone, my name is Bernie Gigas. Thank you for watching my video. I will put a number of videos out on YouTube covering Lake Ontario St. Lawrence River water regulations. And if you would like to discuss any of the content, please contact me on Twitter at Bernie Gigas. The topic I want to cover today is how Lake Ontario levels could possibly be higher without the dam. That's counterintuitive. How can a dam that's holding back water possibly lower the level on Lake Ontario? I'm going to go through this first by covering some basic hydraulics with a little experiment I did in my kitchen. Then I'm going to cover the pre-project flow equation from Caldwell and Fay in 2002 that's used in Plan 2014 calculations. I'm then going to present my pre-project Lake Ontario level calculations and how those reasonably match what the board and the IJC publish on a regular basis. And then finally, I'm going to directly answer the question, how is it possible that the Moses Saunders Dam lowers the level in Lake Ontario? Okay, let's get to work. I've done a very simple demonstration in my house using an orange juice bottle and water to show how basic hydraulics works. In this case, the plastic bottle represents Lake Ontario. The water jet that's flowing through the hole that I drilled in the bottom is the St. Lawrence Seaway. And now note that as the Lake Ontario level drops, the St. Lawrence Seaway flows less. It doesn't shoot as far. The Caldwell and Fay equation describes this behavior with numbers. And over the next few slides, I'm going to cover exactly how that works and what that means for pre-project levels. Okay, here's the Caldwell and Fay pre-project flow equation. It calculates pre-project release flow through the St. Lawrence River prior to the construction of the seaway in the Moses Saunders Dam in cubic meters per second. It does that based solely on the Lake Ontario water level. This equation comes right out of Plan 2014 Compendium Report, Section B2.1 Rule Curves. It can be used to calculate outflow through the St. Lawrence River prior to the construction of the dam and the seaway, and can also be used to calculate pre-project lake level. And that is what the IJC essentially uses to report pre-project lake level. So how do we know this equation is right? I think it's a very fair question. Well, first off, I've met Rob Caldwell and I've talked to David Fay on the phone a number of times. These gentlemen are competent. Second, I sponsored a University of Rochester data science senior project team to help me validate the equation using 1860 to 1953 data. The differences between Caldwell and Fay from 2002 and the University of Rochester data science team results from 2020 are negligible. The end result is that the equation the IJC uses to calculate pre-project conditions, pre-project flow and pre-project level, are valid. Now that we have an equation for outflow, we can put this to good use. We can calculate the change in daily level by taking inflow, NTS, minus outflow, divided by Lake Ontario area. Inflow, NTS, net total supply, is from the IJC and International Lake Ontario St. Lawrence River Board data. And NTS is inflow from Lake Erie, it's precipitation, it's all the runoff, minus evaporation. That's your input of water. Outflow then comes from the Caldwell and Fay equation that we just covered. In crude terms, the area is from the internet. It's adjusted from the data, but it's fundamentally 7,320 square miles or 18,960 square kilometers. It's not exactly the number I use, but it's pretty close. And I'm going to start the calculation on January 1, 2016. Here are the results. What you see here is in blue the lake level, pre-project lake level, calculated from daily known supply, NTS, and outflow from the Caldwell and Fay equation, which then lets me calculate the daily change from day to day to day. And you see that we wind up at a peak of 250.16 feet, or 76.25 meters, on June 29, 2019. Now you can ask, you started your calculation at 244.54 feet, or 74.53 meters. How do you know that that's the accurate pre-project condition on that day? And quite frankly, the answer is I don't. However, if I model the same thing starting a meter lower, at 73.53 meters, 241.28 feet, as of approximately January 1, 2018, it doesn't matter anymore. Conversely, if I start 1 meter higher at 75.53 meters or 247.8 feet, I also, on January 1, 2018, wind up with the same number. And you quickly ask, well, why is that? Remember the orange juice bottle. The higher the lake level, the more water you let out. So if you start higher, you let out more water. If you start lower, you let out less water, and the system equalizes anyway. And in this case, it would take 2 years to equalize or fully equalize, meaning that if I take data from 2 years ago and start my calculation there, I can be comfortable and confident that the number I'm reporting for pre-project level is correct. It also means that the IJC, International Lake Ontario St. Lawrence River Board, reported pre-project levels are accurate. Remember, this is before the Moses Saunders Dam and the Seaway were constructed. All right, taking this to now 2018 and 19. So this is only 2018 and 19 data from the prior plot. The orange line is pre-project level, as calculated using Caldwell and Fay, and the blue line is the actual reported level from the IJC, International Lake Ontario St. Lawrence River Board webpage. It shows that Lake Ontario is consistently below pre-project level. We know the calculation is right. We know the reported numbers are right. How is this possible that with the dam, the lake level is actually lower than we would have had without the dam? Let me try and explain how this is possible. And it's really the Moses Saunders Dam in conjunction with the Seaway. We did not just install the Moses Saunders Dam in 1953. We also dug out the St. Lawrence Seaway with the ship channel. As a result of that digging and blasting, we can now convey much more water than pre-project. As an example, on January 1, 2020, Lake Ontario on that date was at 246.1 feet. Pre-project flow would have been approximately 7,200 cubic meters per second. The actual outflow was 10,200 cubic meters per second. Much, much higher. Since we can convey much more water, we can keep Lake Ontario lower. So the answer is really simple. We can have a lower lake with a dam because we also have the Seaway. Let me summarize. I discussed basic hydraulics and how the Caldwell and Fay equation can be used to calculate pre-project outflow. I discussed how to calculate Lake Ontario level change from inflow and outflow. I showed while we don't need to go back to 1953 data, the completion of the dam, to accurately calculate pre-project Lake Ontario levels. I explained how we can have a lower Lake Ontario level despite having the Moses Saunders Dam, because we also have the Seaway that lets us convey more water. If you would like to discuss any of this, please reach me on Twitter at Bernie Gigas. Thank you for your time. I would appreciate feedback on it, and have a good day.